You know, the Middle East and North Africa are in the middle of this incredible railway revolution. We're talking billions of dollars pouring into high-speed networks and these futuristic city metros. But what does it really take to make sure these massive, super complex projects actually work flawlessly, right from day one? Well, the answer comes from a very specialized field of engineering.
And right at the heart of it all is a group from INCOSE, that's the International Council on Systems Engineering. Their MENA Rail Working Group is basically applying a master blueprint, a set of proven principles, to wrangle the insane complexity of building a modern railway.
So when you've got these massive investments in high-speed trains and smart city metros, you might think the biggest risk is money or maybe materials, but it's not. The biggest risk is complexity. It's the challenge of making thousands of individual parts from hundreds of different companies all work together as one single, seamless machine.
And the vision here is just incredible. I mean, we are talking about a whole new era of trade and mobility. High-speed trains connecting entire nations, and smart metros becoming the literal lifeblood of these futuristic new cities.
But here's the thing. Beneath the surface, it's not just about tracks and trains. The reality is that a modern railway is this massive, technologically intricate system of systems. It's a web where everything is connected, from the tunnels and bridges to the power grid to the digital signaling and all the software humming away in the control center.
And that is where the real challenge pops up. When you have hundreds of different contractors and tech companies all working on their own little piece of the puzzle, how do you make absolutely sure that all those pieces are going to fit together perfectly in the end?
Because if every team just works in its own little bubble, you get this cascade of problems. You get systems that just refuse to talk to each other, you get confusion over who's responsible for what, and you get these bottlenecks where everything grinds to a halt. In the worst case scenario, having to do expensive last-minute redesigns or discovering critical safety issues way too late in the game.
So just to give you a sense of this complexity, you can kind of break a railway down into three big domains. First, you've got the infrastructure. That's the physical stuff like tracks, tunnels, and power. Then there's rolling stock, the trains themselves with all their onboard tech. And finally, operations and control, the digital brain of the whole network. Each one of these is a universe of complexity on its own, and they all have to work in perfect harmony.
So how on earth do you manage all of this? Well, the answer actually comes from a discipline that was perfected in the super high-stakes worlds of aerospace and automotive engineering. You know, places where failure is just not an option.
It's called systems engineering. And to put it simply, it's the master blueprint for the entire project. It's a way of thinking that makes sure every single team, from the people laying the tracks to the ones writing the code, is designing their part with the total system in mind right from the very beginning.
Now, this isn't just some vague philosophy. No way. It's a really rigorous process that's guided by a global standard, ISO 15228. Think of it like the official rulebook that gets everyone on the same page, speaking the same language from the civil engineers to the software gurus.
Okay, so what does this actually look like on the ground? Well, systems engineering gives us a really powerful toolkit with specific methods designed to handle exactly this kind of complexity.
First up is a huge shift in mindset. It's called systems of systems thinking. Basically, you stop seeing the railway as just a big box of parts, and you start treating it as one single integrated system, where every little piece has to work towards the overall mission of being safe, reliable, and efficient. Now, to avoid all those nasty surprises when you try to plug things together, systems engineering uses something called contract-based design. This is so cool. It creates these formal, documented contracts between different parts. So for example, the signaling system might have a contract that says it promises to deliver data in a specific format, and the train's control unit promises to respond in a certain amount of time.
And the result is crystal clear communication. Just like the source material says, this lets different teams go off and build their parts at the same time because they can be totally confident that everything will connect and work together perfectly down the road.
Next up is modular architecture. Honestly, the best way to think about this is like Legos. Instead of building one giant custom piece, you design the railway with these self-contained plug-and-play parts. It makes it so much easier to maintain, to repair, and even to upgrade the system in the future without having to rip the whole thing apart.
And finally, to make sure everything is as safe as it can possibly be, you have independent verification and validation, or IV&V. This means you bring in an unbiased, third-party expert to double-check everything, to make sure the system meets every single requirement and safety standard. It's like having a fresh pair of expert eyes to catch any little thing the main team might have missed.
So we've got these powerful tools in our toolkit, but how do you actually organize them into a clear plan for a multi-billion-dollar project? How do you structure this whole massive effort? Well, the process usually follows a roadmap called the V model. Think of it as a two-way street. On the left side of the V, you plan your way down. You start with the big picture user needs, break those down into specific system requirements, and then into the detailed design of every little component. Then, on the right side, you build your way back up. You integrate those components, you test them against the requirements, and finally, you validate that the finished railway does exactly what everyone needed it to do in the first place. It's a brilliant way to keep everything connected.
And this brings us right back to that INCOSE MENA working group. This is their whole mission. They're trying to share all these best practices, to provide templates and training, and ultimately to build up the local engineering talent to make sure these incredible projects are a huge success.
And the payoff for all this work? It's huge. By really embracing systems engineering, you can effectively de-risk these massive projects. The end result is safer, smarter, more integrated rail networks that actually get delivered, on time, inside the budget, and are ready to go from day one.
Which really leaves us with a final thought to chew on. In one of these 21st century mega projects, where everything depends on thousands of complex parts fitting together, is it possible that the invisible work of creating that master plan, the systems engineering blueprint, is actually more important than the physical steel and concrete itself?